if I can work it. Right, there we go. So today's guest is Keli Chiu, and I get to introduce Keli because I've worked very closely with Keli for more than a year now. And before that, she took my course and she got an A+ in it. And so Keli is just incredible. She taught herself the basics of natural language processing in basically a few weeks. And she then used that to build an R package and Shiny apps that made it possible to reproducibly clean text from PDFs. She got access to GPT-3 thanks to Schwartz-Reisman Institute and Gillian Hadfield for that. And within a few weeks, she worked out how the model worked. She was helping to educate others at Schwartz-Reisman Institute. And she used it to do a whole bunch of different things, including detecting hate speech. And she even gave a presentation on GPT-3 to OpenAI. And OpenAI are the people that made GPT-3. Now, I thought that Keli's brilliance was my secret and I was not telling anybody about it. But then I just randomly sort of I mistakenly mentioned it to another person. And Kelly Lyons said, "Oh, yes, Keli Chiu, yes, she's wonderful." And then I randomly mentioned her to Anastasia Kuzmik, and she said the same. And so it turned out that Keli's brilliance was not my secret at all. She's just unanimously known to be brilliant throughout the entire Faculty of Information. Now, I think we're going to talk a lot about language models today, so I just wanted to have one other example of her work because she's quite multifaceted. And so one particular paper that I really like was she looked at sexism in Google image search. And it turns out, and you can do this right now, if you search Google images for boss at work, you get lots of gesticulating men. And if you Google image search for secretary, you get various sexist images, including arguably sexual assault as the sixth. So Keli's a leader within my research group. I know the undergraduates in particular always really look up to her, and it's just been a pleasure to work with her for the past year. So without any further ado, thank you very much, Keli.
All right, thank you, Rohan, for the wonderful introduction. So thank you everyone for being here today instead of watching the Olympic Games. Today I'm going to share what GPT-3 is and how we use it to detect sexist and racist text. You can see my screen, right? Am I sharing my screen? Okay, that's awesome. So just a heads up that this presentation contains languages that is offensive and even hateful in nature. So if you feel uncomfortable at any point, feel free to have a pause. So a little bit of myself, I just graduated from iSchool last month with the concentration of human-centered data science. I've been working with Rohan, like he mentioned, for a year now on several NLP projects. And I want to start the presentation by showing you how it all starts. So summer 2020, Rohan was looking for a full-time research assistant to start a project on natural language processing. I applied, Rohan thought about it, and I was hired. And this day marks officially the first day of my journey in learning about the field of natural language processing. So in the very beginning, Rohan told me about something called GPT-3. And from the description of it on its official website, I really had no clue what it was. I just knew that the company who created it said it's too powerful for it to be open to the public. So we would need to apply for academic access in order to use it. And we did. Both of us applied and were put on the wait list for several months. But we didn't wait around. During the time of waiting, we built an R package to clean text by Ngram along with the Shiny app to demonstrate how it works. We then improved the package by incorporating BERT, which is the pre-trained language model. What is a pre-trained language model? We'll touch on that later.
Keli, just to interrupt, sorry, are you changing your slide? Are you meaning for us to see different slides? We are still seeing the intro. Is that correct?
Ooh, okay.
Do you want to just hit next?
See my
and we'll
slide.
See if it changes?
Yeah.
You can see the slide.
Okay, so this is where I started the the story.
Okay, so
And
there we
then
go.
scene.
Yeah. Okay, right. This makes more sense with your jokes. Right. Okay.
Okay, never mind. I just ruined my whole story. Okay,
Okay.
I'll just fast forward. I applied. Rohan thought about it, and I was hired. So that's stuff from here, Ashley. So in the very beginning, I really had no clue what GPT-3 was, and both of us, both Ron and me, had to apply for the academic access to it. And we waited. We built in our package during the time of waiting to clean text and everything. Finally, last fall, Rohan told me that he got the access to Shua's Resonant Institute for Technology and Society. They are part of the University of Toronto, and they have a sort of partnership with OpenAI, the creator of GPT-3. And I don't remember what day was that, but I still remember how excited I was that day. And it's from there we started a series of research on GPT-3. Okay, and it turns out I don't have the perseverance to make the entire presentation in comic stripes. So let's go back to the boring and normal slides now. So what is GPT-3? Some of you might have already heard about GPT-3, especially if you work with me. It's one of the most popular large language models that is considered the state of the art. And as I mentioned earlier, it's not yet open to the public, but it has the potential to be part of our everyday life in the future. So GPT-3 stands for Generative Pre-trained Transformer Free. So in machine learning, a generative model is in contrast to a discriminated model. In the case of image processing, a model that tells you if a face belongs to a dog or a human is discriminative, and a model that creates a made-up face is generative. And pre-trained means that the model has been trained. Training is the process of learning for a model, and it usually involves processing thousands or if not millions of examples. So if a model is pre-trained, it means that somebody has already done the training for you, and that will save you a lot of time and money. And Transformer is a neural network architecture that came out in 2017. It's not actually created for text generation, but it works very well for text generation. So Transformer actually worth its own hour-long presentation, which I'm not going to do today, but I would recommend you to at least Google it to see some of its applications, because it's ever since Transformer came out, I think in 2017, it has become the go-to solution for all NLP researches and applications. So finally, 3 just means it's the third GPT model after GPT and GPT-2. So, okay, but what is GPT-3 really? So you can picture it as a robot who is extremely good at generating text that are human-like. So in more appropriate terms, GPT-3 is a language model that uses deep learning to generate text that is hard to tell apart from text generated by human. And what is a language model? In essence, a language model is the probability distribution over sequences of words. So for example, this sequence of words, I think, therefore I X. So I think, therefore is the history. And X is the word the model is set out to predict based on the history. So imagine there's a robot trying to predict the word after I think, therefore I. The robot will go and read all the text on the internet and found out that 90% of the time, M is after I think, therefore I. And 8% of the time, it sees that I think, therefore I exist. And only 2% of the time, it will see I think, therefore I giggle. So the probability is made up here, but you get the idea. In other words, the goal of a language model is to produce the next word based on the previous word. And of course, GPT-3 being a superstar language model, it's much more powerful than that. It can generate not only one word, but sentences and even a whole document of text. So the creator of GPT-3 is OpenAI. They are a research institute in the Silicon Valley, founded in 2015. Elon Musk is actually one of its founders. And he started out as a research-focused nonprofit organization, but then turned to a for-profit institution in 2019, so 2 years ago. So GPT-3 is its latest language model that came out last summer. As they said in their mission statement, they kind of already assume that artificial general intelligence is achievable, and they want to make sure that it's achieved in a way that is safe and beneficial to humanity. Okay, so GPT-3 is actually not the only large language models. So over the past couple of years, researchers and companies have been engaging in this activity of creating larger and larger language models. So GPT-3 was the largest up until sometime last year. But then G# from Google beat it last year. And then Google created an even bigger model this year called Switch C. So I've never played with G# or Switch C, so I don't know how good they are, but it's assumed that the size of the model is directly linked to its performance. But I also feel like I have to mention that although the race of creating bigger and bigger model is exciting, but it's also highly criticized for the potential harm usage of the models and the financial cost and even the environmental cost to train these models. So a paper that listed all the harms and risk is on the dangers of stochastic parrots. Can language models be too big? Highly recommend all of you to give it a read. Okay, so how is GPT-3 groundbreaking? GPT-3 was groundbreaking for a few reasons. First of all, GPT-3 are not specialized in one or just a few tasks. You can generally do anything you want it to do. Second, it learns like humans do. So you just show it a few examples and it will pick up the patterns in your examples and then produce the result following your pattern. And third, the examples and the instructions you feed to the model are expressed in natural language. So in other words, you're programming with plain language without writing any code. So finally, the model generates the text very quickly, very fluently, and the text contents are hard to be distinguished from human creation. We'll see some more examples now. So in this example, I prompted GPT-3 to do an analogy task. I gave GPT-3 a prompt that consists of two analogy examples. The first one is between neural networks and genetic algorithm, and the second example is between social media and a market. So the unbolded text is the output from GPT-3. As you can see, GPT-3 picked up the pattern from the examples I gave to it and generated a few other analogy for me. And you can see it's not only imitating the pattern, it actually produced something that makes sense. So in another example here, we prompt GPT-3 to do a summarization task. Again, we give a prompt to GPT-3 that says, my second grader asked me what this passage means, and then a big chunk of a text that I grabbed from iSchool website. And the last line of the prompt says, I rephrased it for him in plain language. A second grader can understand. So this time we send it a big chunk of prompt, but no example is provided. And people call this zero shot learning. And here is the outputs that GPT-3 generated. He says in the faculty of information, there are many experts who know about information and how to store and use it. These experts know how to help people get the information they need. The expert can help people in organizations and companies do a good job by using information well. So you can see it's not only doing the summarization, but it really makes the language more plain and easy for a second grader to understand. So how is GPT-3 so good? Essentially, GPT-3 is good because it's big. Big means big in parameter size, big in training data size, and big in the amount of compute used for training. So I'm going to use an analogy of a human brain for the sake of better understanding, but it doesn't necessarily represent the correct technicality. So when thinking about the parameter size, you can think of the number of connections the neurons formed in your brain. So the more connections is there, the better your brain is able to transmit signals and informations and make inference. And then when think about data set size, you can think about how many books you read to construct a worldview in your head without the real contact with the world. So the more books you read, supposedly the more details and information you will have to kind of model the real world. And finally, when thinking about the amount of compute, you can think about how much time and energy you spend on reading these books. The more time and energy you spend on reading them, the better you can learn from them. And here are the size comparison between GPT-2, and GPT-3 on the bottom. You can see that the three generations are only 2 years apart, but the magnitude dramatically scaled up. GPT-3 has 175 billions of parameters. And to put this number in perspective, GPT-2 has 1.5 billion parameters, and it was already considered massive. Okay, so GPT-3 was trained on 5 different data sets. The combination of all these data sets altogether is like the past and present of textual history in English. So Common Crawl especially contains billions of web pages coming from many years of crawling. So a few years ago, Rohan and I had the chance to attend to a workshop with OpenAI. And when someone asked a question about if a specific type of data is included in the training data of GPT-3, the team's answer was, if it's online, it's probably in there. So, however, the training data has the cutoff at October 2019. So it actually has no clue about the pandemic that's happening right now. Okay, so someone brilliant said that GPT-3 is like the collective memory of the internet. And I thought it was so accurate. So all kinds of encyclopedias and dictionaries, all sort of public forums and blogs, all kinds of medias and that has different standpoints are all there inside GPT-3. So, however, because it's a container for all beliefs and ideologies collected from the internet, and our human bias is naturally inherited. So it's been reported several times that GPT-3 would generate texts that are inappropriate, offensive, and even hateful. So through my own interaction with it, I've witnessed several times that GPT-3 responded with rude answers that's just out of nowhere. And here are some unfortunate examples. In the first example, GPT-3 generated content that is racist and encourages genocide. In the second example, on the bottom left, I give GPT-3 the prompt asking, what do you think about feminism? And out of nowhere, it said that feminism is the radical idea that women are people. And in the last example, the researchers asked the model to complete the sentence, two Muslims walk into a, and the continuation shows that GPT-3 actually associated Muslim population with violence. Okay, so that was bad. But we also see this danger and misbehaving of GPT-3 producing hateful content as an opportunity. Because if GPT-3 can produce sexist and racist content, it also means that it has the pattern of what those problematic texts look like. And we can use it to detect those problematic texts. So in this part, from now on, I'm going to share how we use GPT-3 to detect sexist and racist content. Essentially, we want to find out if GPT-3 can identify and classify sexist and racist content. And we also want to know if GPT-3 can provide an explanation of what text passage is sexist or racist. And here's how the experiments were set up. For identification and classification, we prompt the model in 3 different ways, namely 0 shot, 1 shot, and few shot. 0 shots means no examples, 1 shot means 1 example, and few shots means few examples. In our case, we give GPT-3 3 examples in the few shot setting. And for the explanation task, we are exploring 2 different approaches. One that's more open-ended and another one that is more structured. We'll see the examples of this setup in the next few slides. Let's start with the identification task. So inside the solid box is an example of the prompt in the 0 shot setting. So we ask GPT-3 to evaluate if the given text is sexist without showing it any example. So GPT-3 will then answer yes or no. We tested 120 passages in total, half in the sexist category and another half in the racist category. So the result is in the table at the bottom. The overall ratio of matches and mismatches is 58 to 62, which will translate to accuracy rate of 48.3%. And then the box on the right is an example of 1 shot setting where we give GPT-3 1 example, the orange text that is labeled as sexist and ask GPT-3 to evaluate the given text in blue. So by providing just 1 example, we can see that the general performance increased compared to the 0 shot setting. The overall ratio of the matches and mismatches is 83 to 37, which we translate to accuracy rate of 69.2%. Moving on to the classification task. Again, the solid box is the example of the prompt. Here we give GPT-3 3 examples, one that is sexist, one that is racist, and one that is neither. So after 3 examples, we ask GPT-3 to evaluate the given text, again, the text in blue. So we evaluated 240 text passages with 10 sets of different examples. And the result is displayed in the table on the right. As you can see, different sets of examples generate quite different results. And the example set that yielded the best result is example 1, which has 77.9% of accuracy rate. So we have 2 main takeaways up until here. First of all, for identification and classification tasks, we learned that 0 shot setting and 1 shot setting are not ideal for sexist and racist content detection. And second, with the fuchsia setting, since different examples yield results that are quite different, the examples should be curated. So if you're interested in learning more about our findings on the identification and classification tasks, we have a paper in preprint that is available on arXiv. So moving on to the explanation task, we are currently exploring two formats of explanations. Here is one of the formats that we are playing with, where we give the passage to GPT-3 and ask the model to generate an open-ended explanation. So we can see that the results are quite reasonable, if not impressive. But we found out that the model is also capable of giving out false explanations. So as you can see in the box on the right, at first, the model said the given text is not sexist, but then because how the second question framed the given text is sexist, it gives me the false justification for the false assumption that I gave to it. And because GPT-3's responses can be very different each time, we prompt GPT-3 5 times for each example to help us examine the variety of the responses and also help to increase the chance of getting a reasonable response. So here are the 5 outputs of the same prompt. Output 1 says it is a generalization about women's sports. Oh, sorry. The problematic text says you should know women's sports are a joke. And we asked GPT-3 to explain why this statement is sexist. So in output 1, it says that it is generalization about women's sports, saying that they are a joke. Generalizations are usually untrue and therefore the text is sexist. So this output mentions generalization, which is what the statement is, but I would say it's not so adequate as an explanation, because if you say men are taller than women, that is a generalization as well, but you wouldn't think that it's a sexist comment. So generalization as an explanation here alone is not enough. And in the second output, it's a straight no. So explaining why you say women's sport is a joke doesn't make it not sexist at all. And the third output, on the other hand, I would say is spot on. It focuses on the word joke and it explains that joke has a connotation of something that is not serious. So same with output 4. Like output 3, it is also point out the implication of women's sports are less than men's sports. And output 5, the first part is okay since it mentions discrimination, but the latter part just seems like a glitch. All right, so here is another format for explanation that is considered a structured approach. We come up with a set of attributes such as target, the presence of violence, derogatory, and profanity. And we showed a few examples to the model on how we want the explanations to be done. And we asked GPT-3 to evaluate if the given text has those attributes in the same format. So this approach actually permits the model to detect problematic text beyond the scope of sexism and racism. Because now the target can be of any groups identified based on not only gender and race, but also religion, sexual orientation, and disability. So overall, the research we are doing for detecting sexist and racist content is an indirect way to study human trust towards AI. So do we trust AI to produce accurate and appropriate content? Do we trust AI's decisions? Do we trust more of AI's decision when an explanation is accompanied? So in terms of next steps, we are looking to have human to explain why a given text is sexist or racist and compare it with answers generated by GPT-3. And some of you might have heard of explainable AI and might have already associated what we do with it. And I thought that's what we were doing as well. I thought what we do was the explainable AI as well, but it turns out it's not. And the reason is because explainable AI is an approach that's okay. Let's talk about what explainable AI is first. So explainable AI is an approach that's been very popular to tackle the black box problem in AI decision making. So oftentimes we have hard time to understand why AI makes the decisions it makes, and there is no way to deconstruct it. So explainable AI is the approach of that decision making process to make that decision making process trackable and transparent. So why we do is not explainable AI because the explanations on why a text passage is sexist or racist provided by GPT-3 are from a social lens, and they are not shedding a light on any technical or systematic process for the output. In other words, the explanations displayed are not the rationale GPT-3 made the decisions based on it. GPT-3 is saying that the text is sexist or racist because of the math behind the model, not because of the explanations that it generated. All right, here are our final takeaways. So we found out that open-ended explanations can be very diverse and hard to control. Second, structured generations can take us to go beyond the scope of sexism and racism. And finally, what we're doing is not explainable AI, although explainable AI is very cool. Again, thank you everyone for being here today. I begged some of you to come today to make me less nervous, and you showed up. That means a lot. And if you have any questions or comments, I will be happy to respond.
Thank you so much.
My voices. No worries.
Yeah, yeah, I can hear. I hope you make it through the rest. I love seeing this project presented every single time I see it. And it's interesting to see how it's grown a little bit. So yes, if anyone has any questions, please raise your hand or put it in the chat. And I'm just going to see if there were any in the chat. It looks like there was one from Monica, if you want to ask, unless it was answered.
Sure. Thanks, Kelly. Great presentation. I was just wondering, so you were talking about the variation in the, sorry, there's a baby. So,
hi, baby.
You were talking about the variation in output with the explanation stuff. I was just wondering with the first part of the presentation, when you were just getting a yes-no classification, was there still variation in the yes and the no's, just even with that?
Yeah, really good question, because initially when we were doing the yes and no part, it gave us variation of answers, like yes, no, maybe. And the whole unique answers is probably like 80 something variety. But just by putting in an instruction telling GPT-3 to answer only yes or no, it actually helped us to narrow down the answers to be just yes and no, and that just makes everything easier. But with the open-ended explanations, we are not able to do that, but kind of in purpose because we want it to be as diverse as we can.
Great, thanks.
So I totally forgot the question that we always ask, which is, do you have any book recommendations for everyone?
Right, yeah, okay. I really want to recommend everyone to read The Anatomy of an AI System. It's not a book, but it's one of the readings that's most influential to me. So if you're in high school, you probably have read it. It's a short essay with visual illustrations on the planetary systems of labors, of supply chains, of environmental cost of making an Amazon eco. And it really strikes me when Kate Crawford, one of the authors, asks the question, is it really worth it to have all these massive exploitations on labor and land of other countries so we can ask Alexa to play a song for us? So I think Kate Crawford published a new book not too long ago. I haven't read it, but I bet it's a book that everyone should read. Yeah.
Thank you. Okay,
No
so